I didn't find a video titled So and so many applications of the supercapacitor, and that is a missed opportunity, because the best way to understand some technology is to give many examples. Let's see if I can come to 8 applications. Hi Norbert here, I'm Energy Engineer. In video number 99, I'll show how to apply supercapacitors in various ways, especially for DIY energy applications. We'll focus on the first project in more detail. For the first application, I will show a real experiment at the end of the video. But first, why are supercapacitors so interesting next to batteries? I say next to batteries because, well, I think together they make a strong couple. I compared also with the bicycle and the train. When I was commuting in the past, I took the bike to the station, and from the station I took the train, and then I went to a place 50 kilometers away. And this combination is really very strong, because with the bicycle you are independent nearly independent of the place of this station. You can come from the home wherever it is, if it's in the range of 15 minutes. That's about 4 or 5 kilometers. And then you can live wherever you want in a range of 5 kilometers. And then you can travel really without a big environmental impact. And that's also with the supercapacitors and the battery. They are just different things, but together, and we will see it in the examples, they are a strong couple. And I will show that in the real life examples, which you can apply also in your daily life. So let's see the supercapacitor advantages. There are 4. They have extremely long life. You can talk of millions of cycles if you avoid overvoltage. Second, they are not so dependent on temperature. They can be used in extreme temperatures, let's say from -40 degrees Celsius to 65. Number 3, they can deliver a very, very high current instantly. And 4, they can provide a very stable voltage on a short term. And that's not so with batteries, because if you go with batteries from the discharge in the charge phase, then you get, for example with a car battery, about 1.5 volt difference. And if you do that very quickly, then you make also microcycles. I will tell about that later. But okay, that are the 4 advantages of the supercapacitor. There are also disadvantages. One is that you cannot store per unit of weight or of volume so much energy as with a battery. And moreover, in contrary to what I said before, because the constant voltage is only for a short term, but on the long term they are not very constant. So if you discharge them, they don't stay like the battery on nearly constant voltage, but they go really zack, like a ramp, they go down. Now let's start with the applications. We start with the one that I promised in the last video, with the battery monitor. Number 1, micro welding. We make a spot welding tool. Work in progress. How it works? Use supercapacitors to discharge a high current through metal strips of nickel and steel to fuse them together on another object like a battery. You can try the 12 volt 83 farad supercapacitor bank like I have here, but also with smaller capacitors, like I saw in some videos that they worked with 40 millifarad. I just had this supercapacitor bank for my previous video, that one with starting the car, which is also fine for some of the following 7 examples. Then I use also a car lamp in series with these 2 welding probes. It's a temperature-dependent resistor, and starting from cold, it will give a very strong starting current to form the very hot spot in a fraction of a second, in a way that the battery will not be damaged at the inside. It's so quick that the battery even doesn't notice what is happening. And then getting hot, it limits the own resistance tenfold in a second or so. Therefore, it will not end up in a mess. You have better control. Okay, it is only intuition. I have to try, and you will see it at the end of the video. So what is the value for DIY? You can connect this kind of cells. If you consider that they are even in the electric vehicles, they are more or less of this format. So you see them everywhere, and you can recycle them from old applications and then take them, test them singularly, and then take the bad ones out. You can also connect and not batteries but super capacitors, because they need very high current connections, and with the micro welding you can do that. What's also fun for DIY is that you can try with so many materials. So for example, this is a 15 micrometer of copper. You will see some experiments. It's a whole other material, but you can also try with, for example, wires. But mainly you will use this kind of strips, which you see always on battery packs, like this one, which comes from a drill machine. And it is also great for decorative work, because it's very quick and it's nearly invisible. And finally, for DIY, I think it is less dangerous than other types of welding, especially if you put this lamp in series. Number 2. Solar PV boost support, or in other words, power smoothing. How does it work? Well, supercapacitors react much faster than batteries. Batteries are chemical instruments, and supercapacitors are not. They can absorb solar spikes or dips during a cloud cover, but also the shadow of a bird can give a shadow and then a significant dip in a PV performance for a moment. The supercapacitor avoids the jitter in the voltage and protects the battery also from microcycling, extending its life. Cycling happens when you have a battery that is giving power, and the PV module will give power that is more than what the battery is giving, and that will turn the current direction in the battery around, maybe many times in an hour, and that is microcycling, and that comes on the cycle counter of the battery. What is the DIY value here? You can connect supercapacitors in parallel with a battery, for example in a lithium ferrum phosphate, or just LED batteries like in a car. And I have many videos where I do just that. Another value for DIY is, as I said, that it will reduce the wear and tear on a battery, because the direction change of current in a battery will change also the chemical reaction, and this chemical reaction, that is also what gives the tear and wear of the battery. And this combination of supercapacitors and batteries will also allow a smaller battery to give more power. And indeed, some people have to buy bigger batteries, not for the sake of the energy, so the capacity of the ampere hours or the watt hours which are in a battery, but for the sake of the power. For example, in a car, you could well do in many cars with the battery which is only the half of the actual size of the battery. But then you cannot do that, because then this size, this reduced size, would not be able to give those several hundreds of amperes of current for the starting motor. Number 3 is the input buffer for the DC-AC inverters. We go now to the consumers. So the battery gives, for example, the electricity to the inverter. And then you have another problem, because at the other side of the inverter there's a consumer that might consume in a very irregular way. For example, take a refrigerator. It has a starter current of maybe 7 times bigger than the nominal current. And then a super capacitor will be able to give that burst of power. So you have an inverter, and in order to start the inverter, the compressor in a refrigerator, it will need from the inside a large starting current from the battery. And that starting current will be given by the super capacitor if you put it in a parallel with the battery, or at the input of the inverter. That's the same thing, more or less. But then you have also to be very careful, because the supercapacitor is so strong that it can burn the input stages of the inverter. And therefore you have to see what is the peak power of the inverter. That is usually the double of the continuous power. So for example, if you have a refrigerator with a nominal power, so the compressor has a power of 100 watts, then you would say, okay, 100 times 7, that's 700 watts. And that would mean that if you take the half of that, that is then the continuous power of the inverter. And then you take that, for example, an inverter of 400 volt continuous power. And then you are, theoretically, you should be able to start the refrigerator, but you have still to try. I have, for example, a 500 watt continuous power inverter, and then I had a normal fridge, and you heard every time that it started, you heard the inverter giving a weird noise. But okay, it started. And in these cases, if the inverter doesn't have a fuse on the input, then you should provide it. Or you put a soft start resistor or an NTC thermistor. That will limit this inrush current, this starting current, but of course it will also make it more difficult for the refrigerator to start. Well, what is the DIY value of this experiment? Well, take an example. I talked already in the past about this microinverter. It's not so micro, because it's 2 times 300 watt. It's one of those things that you put between the PV panel, that are typically those balcony systems. And then you can put this combination of the PV panel and this inverter directly to the grid. So the output of this inverter you can put to the grid. Just put a plug and you push it in the outlet of the home, and then it will add its power to the home grid. And that is very practical, because then you have the power of the panel is not there somewhere isolated on the balcony, but it goes everywhere in the house. But the typical challenge of this balcony system is that the power can go to the electricity meter from the wrong side, from inside to the outside. I talked about that already in the previous video, and I want to solve that with a battery, even if this is not made for a battery. So stay tuned to see that video, because it will solve the problem that you cannot bring electricity to the outside of the grid if you do not do some bureaucratic work. In any way, it is not so convenient. Well, batteries are great to be more independent and to keep more of your solar energy from the balcony system inside your house without giving it away for a dime. But supercapacitors are already a good step in the right direction, even if they contain much less energy than a battery. But at least you bring some stability in the power supply from the solar panel, from the balcony system, to your grid. So actually it's a few seconds of UPS, uninterrupted power supply. This is a real UPS, but it is heavy and it's also expensive. Okay, this can be very useful for routers, for microcontrollers, for example, Raspberry Pi or Arduino, or maybe smart home systems like the Amazon or the Google, or you have also the home assistant, which I showed in some video before. Well, supercapacitors can provide instant power in such a case, so that's very quick. Batteries, especially with lead, they can be slow because they depend on a chemical reaction. Lead can actually be slow as long as a second. Brownouts are a kind of grid instabilities which are usually not so severe as blackouts. They are even maybe not a complete power down. Maybe it goes down for 50% or so, or it is very short. It can come from the outside, from outside your house because of a grid instability, but also there can be an overload in your house. And the brownout can last from a second or so to some minutes. They are very common during heat waves and grid switching. Well, even if a router takes 1 ampere of a 12 volt power supply with 80 farads, which I have here, that will give in 80 seconds a voltage drop of 1 volt only. For a computer, a super capacitor bank could give you the time to power down the computer in a regular way, maybe also saving 1 or 2 files. And then this power bank, this capacitor bank will outlive your computer many times. And the DIY value of this is that you save money because it is easy to build, and for some important devices it can save you during many brownouts. You can keep your data safe and running without interruption, and it is a long life. That's also DIY value, that you can use it for this and many other applications. Number 5, the DIY car battery booster or jump starter. Why is it interesting? Well, even with this 6-pack of 2.7 volt 500 farad supercapacitors, you can start a car. It costs a little more than 50 euros, only these supercapacitors. And I made several videos about it. You can see it in the playlist. This video of today is my compensation for you, as I am stopping the project because I have no car which I can use for my experiments anymore. And the DIY value is that you can now make a car booster by yourself. This supercapacitor bank recharges in a few seconds even from a weak battery, but even from a small solar panel. If you take a 50 watt solar panel, then that will give the needed 11 kilojoule needed to start a car in 5 minutes. So if the sun shines, you can start as often as you want. It is safer than lithium-based jump starters. And the supercapacitor bank is very light. It's compact and ideal for this and many other applications, as I said. I give you 8 applications, so with one 6-pack you can do all that. I give you a warning, which is also the reason that I had to discontinue this project with the car starter. You should include a fuse between the alternator and the supercapacitor, so also the battery, because they are together. Or you can also use a small resistance, 30 milliohms, also between the alternator and the battery. And that will protect the alternator to give too much current if this supercapacitor must be recharged. And now, if you liked the video until now, please push the like button, subscribe to the channel and share it with your friends. I am sure that they need it. We go on with the last 3 tips, quick tips for the application of this mysterious device. 6. We talk about one-time jobs. For example, pumping an amount of liquid, for example water, once in a while, opening a gate, running a fan for a few hours, keeping the light on during the night so that you will find the room when you have to get up in the dark. Or in case of a blackout, that you have light for a couple of minutes or a couple of hours. And the DIY value is here, that you have unlimited cycles. These are really, if you're talking about 1,000,000 of cycles, it will outlive you even. Another DIY value of this experiment is that you can recharge it with very low power. And that depends, of course, with which frequency you have to do this task, opening a gate or whatever. Number 7, the energy harvesting buffer. It's the exact opposite of the previous application, because there the consumer was very infrequent. And here we have the power supply, which is infrequent. So you can, for example, think about input from piezoelectric devices when someone moves, thermoelectric generators or mini wind turbines. Or your own muscle energy if you feel motivated. And then you have the power which you can release steadily. The DIY value is that you can use it for self-powered weather stations or sensors. You need to take here supercapacitors of a high quality which have a low self-discharge. And the other DIY value is that you have so many applications where you have a source which is sometimes it gives a little bit of energy and then you can use it. There are so many things that you can invent, and that's also fun. And then number 8, the off-grid or harsh climate power source. If you have a place where there's no grid and you can give little maintenance and attention to some consumer. I'm talking about gardens, about second homes, or also outdoor equipment. And the DIY value is that you can give power to devices which are really a problem. You need them, but it would be very expensive to provide power in another way. I am talking about actuators, I am talking about relays or lights. There are so many things that are in those places that need a little bit of power, but it is important. And you can always recharge it with a small solar panel. And it's not so important with the voltage regulation like it is in a battery. The only thing is that you must not go over the voltage limit. So you have only a maximum, and not with a battery that you have a kind of a window where you must stay inside. Here's the Super Capacitor bank of 12 volt with its balancing circuit here. And here are the connections, these big green connections, the minus and the plus. And I connected it now with these provisory contacts to these pins. And then I have here my current source. It's now very low. It's just arrived at 6 volt. and it's 300 milliampere, so it's very little. I want to try with 6 volt. There we are, arriving at 6 volt. And this would be the typical working area to do this kind of contacts. You cannot use a soldering iron to heat this up. That's not good for a battery. You can imagine what I think about this one. So we do it with these pins, and these are now under tension, so you have to be a bit careful. And I have already some copper material. This is 50 micron, so that's very thin. And if I understand well, these kind of tin plates or whatever, steel plates, they are about 100 microns, I think. Well, that's very well behaving. You feel that it sticks with 6 volt. It also already at 7 volt, but it went now down to, yeah, half a volt. It goes down with one touch. It's now 3.6. I touch it and it goes to 3.3. Yeah. You see a little bit traces of molten metal. So that was playing around a little bit, and now we go 3 ampere into it, and it will go up to 12 volt. For example, if I put this to 12 volts, so playtime is finished. And then of course you will also see the balancing LEDs. That will glow up if we arrive at 12 volt. So this is now an experiment with a very narrow film of 50 micrometers. So it works as a fuse. Now it breaks here. Oh, it is red, glowing red, all through the wood. You see it now. And it's still 12 volt. Okay, it is now charging 5 ampere. Now it is at 10 volt. And now again at 850. Yeah, okay. It was pretty good. It was not 12 volt. It makes holes, it's too strong. So I show you again. We had 12 volt. It works. This even works good. Yeah, quite well. Maybe multi-points. I don't have to insist too much because it will break, it will burn holes. Maybe the short is sacred. Yeah, that works well. Anyway, I think it would be interesting to try with an inductance, which would maybe amplify the effect, and with the time pulse. Maybe I can also try with less voltage, with other pens, or with other times. Now my idea is to use the PTC character of a lamp, because you see it is very slow. It's now 10 volt and it's slow. You see it, it's slow. And also this is slow. This does now the spiral. And I can also put it in series, 2 spirals, and then they work, both of them. And the idea is that I want to use the PTC in such a way that the first current, the start current, is very high in this micro welding, and then it will go down quickly. So that means that the arc is formed, but then when the arc is formed, the current will be limited. Otherwise it will be difficult to weld, and it will be too intensive. I want to try both, without and with lamp. I do it now with the lamp in series, and you see it's too weak. It does nothing, so even the surge current of the lamp, the cold current, is not enough. Here you have the list, the complete list. And let me know in the comments which of these applications you would like to do first. And don't forget to like, to subscribe with the notification for more energy-savvy DIY content. I wish you good energy.